like our this is the matrix element of Hamilton. But what you need is not that. You needed the matrix element of the E minus beta H. Yes. I want to find that. And one dimension. You can do this in the D dimension of harmonic oscillator. Again, you have a completeness condition. So completeness means that sigma n and n is 1. So I will substitute that 1 here, and I will substitute the 1 here. So rho will be sigma n, sigma m, x n, e minus beta h, m, x prime. What is xn? Xn is sine n, x is the wave function, and this is a sine m star x prime. And what is that? The benefit is that just when you have this representation, you can use it this h over n is h power omega this. So exponential of that will be exponential of minus beta h power omega m plus 1 over 2 n over n. And they are normalized again. You remember this is you should remember my previous example. Is it similar to the particle in the box? But that example was by the sigma. Sigma was converted to the integral because the eigenvalue of momentum was are continuous actually, not like the eigenvalue of Hamiltonian here or discontinuous or discrete actually. So 2 sigma will be changed just to the 1 sigma. Okay, so you need to find this integral, this sigma actually. And sine n, what is the sine n? Sine n is this. And n is equal to m. Sorry. So if you just substitute the expression of the wave function for the harmonic oscillator, you will find sigma n0. I'm continuing with this. E minus beta h for omega n plus 1. Psi nx. What is the psi nx? Cross psi nx prime. So many things are here similar, except that the next expression x will be x prime. Okay, so just a little bit work with that. I mean, put it outside the what is not n, and keep it what is have n inside the this. So will be radical m omega ph bar exponential minus beta h bar omega over 2 from here minus m omega 2h bar x squared plus x prime squared sigma n 0 to infinity h n radical m omega this. We needed to know that what is the sigma Hermite to n factorial this. So you have no more option that to check the chapter of the special function from any book of the mathematical physics. So if you pass to those chapters, we have to know that what is the sigmoid. This is our problem. Hn kc, for example, Hn kc prime 2 power n factorial exponential minus what? Alpha n, or not alpha, even more easy. Zn. Z power n. What is the z? If you want to understand what I'm doing, for example, I can take this as a z, and I take kc as this, and kc prime as this. Just change the variable. So you need to know what is that. Sigma hermetic is hermetic is hermetic. This is you needed to check the chapter of special functions. It will be exponential of the somethings. But I want to keep this for you, just because you will need to check the Arfken Weber, and Weber, mathematical method for the physics. Physicist physics. You need to keep this book always with you if you want to do the work in physics. So if you just go and find this expression, or you can check at the textbook, our textbook. In the textbook they write like this. So you can find that and put this here, and you will complete the expression of it. To make the trace, so when you find that, you needed also the trace. So trace will be again sigmoid rho x prime, integral the cubic x, not cubic, one dimension, just x. It's funny that if you do this calculation, you will see that this will be a function of the x minus x prime. You will go and see. Multiply to something, which I don't know. So when I said x equal to x prime, because I needed here, because I needed to have the rho xx. So it means that x is equal to x prime for the rho. This term will be cancelled, and you just have this term plus some constant here. But everything depends to this, so you see that working for the harmonic oscillator, finding the rho. Of course, if somebody asks you what is the rho matrix, you need to go to the von Neumann theorem. But if just somebody asks you what is for example, the average of the energy in harmonic oscillator,